Okay, so in today's lesson, we're looking at day 2. So we're continuing with solving quadratic equations by factoring. We're going to look at an application and then how we can factor now to graph. So kind of backwards of what we did on the first day when we graphed from standard form and then used our graph to write it in factored form. So for this one, we're going to look at a museum vault that has an outer steel wall with a uniform width of X. So that's labeled, we have the X labeled there. That X is that width of the wall. The area of the museum vault ceiling and the outer steel wall is 1,664 square feet. What is the width of the outer steel wall? So we can see from the diagram that they're showing us the inside dimension of that wall. So what we want to think about is that if I want to find the entire length here, I have an X on either side, right? That's an X and that's an X. So there's 2X that's being added to the length that's labeled, which is that 40 feet. So 2X plus 40 would represent that length of the wall. And then I have to do something similar on the other side. So they're telling me that I have 20 feet inside the vault plus that X on either side. So if I want to find this whole width of the vault, I have an X being added here and X being added here. So I can think about the expression 2X plus 20 as representing that width. And so they're telling us that the entire ceiling, so meaning like if I was covering up all the way here, that is represented as an area of 1,664 square feet. And so that 1,664 is going to equal the length times the width of that vault that we created. So that means that's going to be equal to 2X plus 20 times 2X plus 40. For that value. So what we're going to have to do is multiply out that 2X plus 20 times 2X plus 40 and then solve. So when I'm solving by factoring, remember that our goal here is to get an expression that is equal to 0. So right now we have an equation equal to 1,664. So I can't just like move that over and then have the factored form. I need to write this in standard form so that I can then factor afterwards. So I'm going to multiply out the right-hand side. And so that's going to give me 2X plus 20 times 2X plus 40. I'm going to write the 40 across the top, 2X plus 40, and then 2X plus 20 down the side. And so when I multiply those together, I get 4X squared plus 80X plus 40X, and then 20 times 40 is going to give us 800. So that means that I now have that 1,664 is equal to 4X squared. 80X plus 40X is going to give us 120X plus 800. So in order to get it equal to 0, we want to subtract that 1,664. We're going to move it over to that side because we want to always keep that a squared positive so we don't have to forget, or so we don't accidentally forget to factor out a negative from our GCF. Okay, so we've got 4X squared plus 120X, and then 800 minus 1,665 is 864. Okay, so when we factor, remember that we want to start with looking for a GCF. And so if I look at the first two numbers, I can see that they're divisible by 4. And then 864 is also divisible by 4. And so I can factor out a 4 from every term. And so that will make my factoring a little bit easier for the problem, because now I just have 1x squared. When my a is 1, it's a nice factoring method. So 120 divided by 4 is 30, so I get x squared plus 30x. And then negative 864 divided by 4 is negative 216. So what this means is that instead of having to multiply 4 times negative 864 to find my factorization, I'm just going to have to see what multiplies to negative 216 and adds to positive 30. Okay, so I know I'm going to have an x plus and an x minus because I'm multiplying to a negative. I also know that my larger number is going to be positive. So when I'm looking for this product sum, I'm looking for two numbers that multiply to negative 216 and then add to 30. Okay, so when I'm looking at that factorization, the two numbers that are going to work are negative 6 times positive 36. So I'm going to have x plus 36 times x minus 6. So remember that what you should be doing on a question like this is listing out all your factors, right? Starting with 1, 2, 3 goes in, and keep trying until you find a pair that works. For an assignment, though, you could look up factor lists for numbers larger than 100, since you won't have that on your test paper. Okay, so once I have factored form, that's going to allow me to solve for x. So remember that our kind of big idea here is that each factor I would set equal to 0 to figure out what x is. So I'm going to take each of my 3 factors and set them each equal to 0 to figure out the value of x. So my first factor is just the number 4. So if I set 4 equal to 0, that has no x for us to solve for, so that's not going to affect our solution. Then if we set x plus 36 equal to 0, that's going to give us an answer that x equals negative 36. Okay, so x equals negative 36. Remember that x represents the width of that wall. So what we would know is that we're actually going to eliminate this one. This one we did it because there was no x to solve for. And this one we're going to eliminate because a length can't be negative. And so that means that we better get an answer for x minus 6 equals 0, otherwise this has no solution. So x minus 6 equals 0 tells us that x would equal 6. And so that must be true. That tells us that the width of the outer steel wall must be 6 feet. Okay, so that is the answer for that problem. So in that problem, we had to write an equation based on the situation that they provided. For example 4, we're going to use factored form, so our intercept form of the graph, to solve and graph a function. So what we're going to do is we're going to factor the related quadratic equation to write it in intercept form. We're going to use that to determine the zeros and find the coordinates of the vertex. And so when I'm doing this, that means that I want to write out my factors of this equation. So I want to be able to rewrite f of x as a product of 2 factors. Notice that in this problem, a is 1 And so that's nice because that means that in our factored form, A will also be 1. It also means that we don't have a GCF. So when I'm factoring this, I'm just thinking about the product sum table so that I can find two numbers that add to our B, which is -2, and then multiply to C, which is -8. So I'm looking for two numbers that multiply to -8 and add to -2. And so those two numbers would have to be -4 and +2. So I'm going to have an x minus 4 and an x plus 2 as my factors. Remember that with multiplication, either order is appropriate. So I could write that as x plus 2 times x minus 4 as well. And so my simplified version of the equation would not have that 1 there for the function. So what this tells me is that if I take each factor and set it equal to 0, so for my first factor, x minus 4, that tells us that x would equal 4 for the solution. And then if we take the second factor, x plus 2, and set it equal to 0, that would mean that we have an x-intercept at -2 if we solve that equation. So what these two numbers tell us is that our graph has the following x-intercepts. So remember that an x-intercept is when I plug in an x value, it gives me 0 as y. So those are also called zeros or roots. So our first x-intercept is going to be at 4, 0, so at 4 on the x-axis. And our second one is at -2, 0, so at -2 on the x-axis. So we know that we can find the vertex from standard form using -b over 2a. So remember that we learned that h is always equal to -b over 2a. One thing that is easy about a parabola and finding the center is that when I'm looking at my x values, I can actually just find the middle of my two x values to determine my axis of symmetry. So if my graph is crossing at -2 and +4, when I plot those points on that visual of my graph on paper, then I can see that my axis of symmetry would have to be right down the middle. So I can use -b over 2a to find h. The other thing that I can do is I can add my x-intercepts together and divide by 2. So I can take 4 plus -2 and add those together. And then that gives me 2. And then if I divide that by 2, that gives me 1, which is where my h would be. Okay, so I'm going to get 1 for that value. I'm going to change it to blue. So x equals 1 is my axis of symmetry. Again, I can do that visual like I did first, add my two x-intercepts, divide by 2, or go all the way back to the beginning and do -b over 2a. Okay. So remember that regardless of how I find that value in my vertex, I now know that I have to plug 1 in to find the k value. So to find k, I'm going to evaluate f of 1. By plugging in 1 squared minus 2 times 1 minus 8. So I'm going to plug that h that I got of 1 into each x in my equation. And so 1 squared minus 2 times 1 minus 8 is going to give us a k value of -9. So our vertex is at 1, -9. And so now I have those 3 points. If I was graphing on screen, I would have to do that vertex and the one on the right because this is the up-facing parabola. Because a equals 1, remember that our pattern is just 1, 3, 5 for our y values. so I can make my graph look a little better by going out 1, up 1, out 1, up 3, and then I can see that the x-intercepts are 5 from that point. And so that will allow me to graph the parabola nicely so that it shows me those values. Okay, so when I'm graphing using factored form, I have to factor my equation if it's not factored already, use that to determine my zeros so that I can find the coordinates of the vertex. And then I can plot the vertex and the x-intercepts to sketch my graph. So I didn't necessarily have to draw those additional sets of points, but it's helpful for the graph. We're going to do the same thing for B. So notice that for B, I do not have an A that is a GCF. So this factored form is going to look a little different in that my A value is not apparent from the problem. So I am going to have to find that axis of symmetry and then just graph using those x-intercepts. So from my equation, I can see that A is 2, B is 5, and C is -3. So remember that when I'm factoring this, because A is not 1, I'm going to have to factor by grouping. So when I do my product sum, I'm not finding the opposite of my zeros like we did in the last problem. We're finding how we're going to split that x term out. So remember that we have to multiply A times C, and so that's going to give us -6, so that our factors add to 5. So 6 is one of those ones where you have to be careful because my two factors are either 1 and 6 and 2 and 3. And so if I don't pay attention to the sign here, I can pick the wrong set of factors. So if I needed to multiply to -6 and add to a positive, that means that the small numbers need to be negative. And so that means that the -1 and the +6 is the pair of factors of -6 that we have to use to factor our related function. So that means that we have a -1x plus 6x as our split of that middle term. And so in this problem, we're going to have to factor by grouping, again, because A wasn't 1. And so that means that if I look at my first two factors, I have a GCF, or first two terms, I have a greatest common factor of x. 2 and 1 have no numbers in common. So when I factor out a GCF of x, I'm left with 2x minus 1. So that tells us that if we did this correctly, we should have a 2x minus 1 left over for our second pair. And so I can see that if I factor out a 3 times 2x makes 6x, and then 3 times -1 makes -3. So that means that my first factor is that common binomial factor of 2x minus 1, and that my remaining factor is the GCFs as a sum, so x plus 3. So if I'm looking at this, in order to find my solutions, I'm setting that equal to 0. So in my first factor, 2x minus 1 equals 0 means that I'm going to end up with a fraction for my answer. So if I add 1 to both sides, I get 2x equals +1, and I would have to divide by 2 in order to get x by itself. So that tells us x equals 1/2 is one of our x-intercepts. Okay, so we're going to plot the point 1/2, 0. So that would be between the y-axis and 1. And then our other factor is just x plus 3. And so that one's the nice kind where if I have x plus 3 equals 0, I know that I'm just subtracting the 3. And so I could use that shortcut and say that x is -3. Okay, so if it's -3 on the x-axis. So for this one, it's a little bit harder to see where that axis of symmetry should be exactly, because I have 3.5, right? So it's half of 3.5 boxes across. So remember that you can use either method. I'm going to continue to show you using the average. So h is going to be the sum of my 2x-intercepts. So I'm going to take 1/2 and -3. And I'm going to find the middle by adding those together and dividing by 2. So half of 1/2 plus -3 is half of 2.5, which ends up being 1 1/4. Okay, so -1 1/4. -1 1/4, or 1.25. So looking at that, that would be here as my axis of symmetry. Okay, so I just need to plug that value in to find K. And so K is going to equal that -1.25 plugged in for X. So if I have 2 times -1.25 squared plus 5 times -1.25 minus 3. And if I were to plug that into a calculator, it would tell me that my y-coordinate of my vertex is -6.125. So -6 1/8 is where my vertex will lie. So it will be down a little bit past that -6. And again, I can just use these points to draw my graph. It should have an A value of about 2. And I can see that as I draw those curves that it does stretch in that direction. And our last pair of examples for today is really the opposite of what we were doing here. And so from these, what we're going to be able to do is determine the value of our x-intercepts and A, to write that intercept form of our equation. And so when I'm writing that intercept form, I want to be able to find those two things. So what I'm first looking for is my x-intercepts. And so from this, I'm looking for when is y 0 on my graph. And so I can see from this graph that I have an x-intercept at -5. And then also I have an x-intercept at +1. I can see from my graph as well, oops, I meant to get a highlighter, that my axis of symmetry is going through -2. And so that axis of symmetry tells me my h value of my vertex. So I can see that my axis of symmetry is at x equals -2 from that. And so this visually should be able to show me what A is. So remember that if I look at my graph from that vertex to if I were to go out 1 in either direction, as far as I need to go up or down to get to the next point on the graph, so the next point on the graph would be at -8, how far I have to go up, that tells me my A value. So notice that I'm just going up 1 to get to that next point on the graph. If I think about the same idea on this one, you can see that this graph is going up. It's going by 2s. And so for this one, that's going up 2 for that point. And I can always double check. Remember that if A is 1, that would mean that the next group of points should go up 3. And I can see that, and then up 5. So that does confirm for us that A is 1. And so for our equation, we're going to write f of x equals, when A is 1, we don't write that number in front. Remember, it's always x minus each x-intercept. And so if my x-intercepts were at -5, I'm going to have an x plus 5 as one factor. And then the other one was at +1, so I'm going to have an x minus 1 as the other factor. Okay, so my A value is 1. I don't write it in that equation. For this next graph, I didn't highlight the axis of symmetry, but we looked at the vertex to the next point. So we can see where our vertex is. and at the next y value, we went from negative 18 up to negative 16. So that told us that for our equation, our a value is positive 2. Remember, if it's pointing down, that would mean that the a value is negative. And so then what we're looking for is where is our graph crossing the x-axis. So looking at the x-intercepts, remember that those are also called zeros or roots. We want to find the coordinates of the points. And so our first x-intercept, it looks like, is at negative 9. So that would give us a factor of x plus 9. And then our other x-intercept is at negative 3. And so that would give us a factor of x plus 3. Okay, so our equation of f of x would be 2 times the quantity x plus 9 times the quantity x plus 3. Remember that the 2 should always be first, but the x plus 9s and the x plus 3s can be switched, and you would still be correct as long as they're both positive, as long as they're both sums. And then same thing with the other one. I can write x minus 1 times x plus 5, but I can't switch the plus and the minus between the 1 and the 5. Okay, so that is graphing using factors and then taking an equation and writing it back into that intercept form.